All right, so here we go. We're going to go through problem number 2, where we have a mass on the ground that is a 5-kilogram mass. There's the ground. It's being pushed at an angle of 30 degrees. So there's a force acting on it. That way, oh gosh, I can't even draw that. So it's being pushed this way. And that's 30 degrees relative to the horizontal. That's our applied force, which is 20 newtons. And we know that the coefficient of friction, the coefficient of kinetic friction, is 0.2. All right. Is that all we know? That's all we know. Right. Drawing a free body diagram. All the forces acting on it. Well, Earth is pulling this thing down. Gravity is pulling it down. mg. 5 kilograms times 9.8 meters per second squared. That's going to be 49 newtons. If you were to use 50, it wouldn't be a big deal. The ground is supporting it. We don't know by how much. So there is a normal force. It's being pushed this way at an angle of 30 degrees below the horizontal. And that push is 20 newtons. The applied force, draw that better. The applied force is 20 newtons. Now again, some of that pushes to the right, some of that pushes down. And since there is friction here, we know friction always opposes motion, so friction goes that way. There's your free body diagram, 4 arrows. Gravity, support force or the normal force, frictional force, and the applied force is at an angle. That applied force is an angle. When you go to do the sum of the forces, you have to split that force up. So let's see, let's look down here. If we had that force at an angle, that's 20 newtons. And some of that force is to the side this way, and some of that force is down that way. If that angle there is 30 degrees, this vertical piece, the downward piece, is opposite to 30 degrees. So this is the opposite side, which means that the length of that downward arrow, the amount of force that's down, is 20 newtons times the sine of 30 degrees. Sine of 30 degrees is a half, so 20 times a half is 10 newtons. And the horizontal piece is the adjacent side. So that's going to be 20 newtons times the cosine of 30 degrees, which is 0.866. 20 times that gives you 17.3 newtons. That's the force in the x direction. I should say that's the applied force in the x direction, and the applied force in the y direction, the force applied in the y direction is 10 newtons. Really important to figure that out, because now when you go to do your problem, the next step is always to do some of the forces in the x, some of the forces in the y. So here we go. we have to find the force of friction. The force of friction is in the horizontal direction. So let's go that. The sum of the forces in the x direction equals ma. Well, let's see what forces are acting in the horizontal direction. The applied force in the x direction plus the force of friction equals ma. We're going to make to the right positive, to the left negative. So basically the applied force in the x direction minus, because it's to the left, we're going to make that negative, right? So because this is left, we're going to make it negative. So the force of friction is negative. Minus the force of friction equals ma. So 17.3 newtons minus the force of friction equals 5 kilograms times the acceleration. Well, we need to figure out the force of friction. The force of friction is calculated by the equation, right? There's an equation to calculate the force of friction. The force of friction is equal to mu times the normal force. We know mu, but we don't know the normal force. We can't calculate the force of friction until we know the normal force. The normal force is in the y direction. So before we can do this, we have to do the sum of the forces in the y direction. So let's go sum of the forces in the y direction. Sum of the forces in the y direction equals ma. Well, you can kind of assume that the box is not moving up or down. It's on this floor here, and it's being pushed to the side. It's not being pushed into the ground, or it's not moving into the ground or flying up off the ground. So this is all going to equal 0, which is quite helpful. So let's add up our forces in the y direction. We have a normal force, which is up, which is positive, because that's up. Gravity is down, right? So remember, we're going to think of that as negative because it's down, force of gravity. And a bit of the applied force is down, force applied in the y direction. All that equals 0. Again, really important to recognize that the gravity is down and this is down, so those are negative. Down is negative. All right. Now, I'll just move this up a bit. So the normal force, we don't know what the normal force is yet, but with force of gravity, we do know that was 49 newtons. The applied force in the y direction, we figured out, was 10 newtons equals 0. So what minus 49 minus 10? So the normal force minus 59 newtons minus 59. Why am I erasing? I want to erase. Minus 50. Minus 59 newtons equals 0. So the normal force is 59 newtons. That's going to become really important. Remember, if we want to figure out the force of friction, we need the normal force. All right, so let's go to figure out the normal force, because that's all those forces in the direction. So if you figure out the normal force, to figure out the force of friction equals 0.2 coefficient of kinetic friction times 59 newtons. All right, that's not a complicated math problem. Grab a calculator. We have 59 times 0.2. I think it's 11. 59 times 0.2 is 11.8. All right, so that's 11.8. The force of friction is 11.8 newtons. Well, that we can bring over here. So now we can come back and figure out that 17.3 newtons minus 11.8 newtons equals 5 kilograms times our acceleration. 17.3 minus 11.8, 5.5 newtons equals 5 kilograms times A. A is really what we want to solve for, right? That's the last part. So divide both sides by 5 kilograms. Divide this by 5 kilograms. 5.5 divided by 5. 1.1. 1.1 meters per second squared equals A. So we've got all of our answers here. But the key thing really to recognize is you have to break this force into its horizontal and its x, its horizontal and its y component.